Today we'll talk about the basics of hypothesis testing, terminology and steps. This is from our chapter 8.1 of our textbook. What is hypothesis? In statistics, a hypothesis is a claim or statement about the property of a population. Population proportion, abbreviated P, population mean, abbreviated mu, or population standard deviation, abbreviated sigma. A hypothesis test, also called a test of significance, is a procedure for testing a claim about a property or a population. Here are some examples of the claims. To write a claim in symbolic form, we're going to use the signs less than, greater than, or equal. To write an opposite claim, we use also the greater, less, or not equal signs. So here are the examples. The mean body temperature of humans is less than 98.6 degrees Fahrenheit. We are talking about mean in this case. Therefore, we will be testing population mean, mu, and it says that the temperature is less than 98.6 degrees Fahrenheit. So we use less sign, 98.6 degrees Fahrenheit. Don't forget about units of measurements. Next statement. The proportion of consumers not comfortable with drone deliveries is greater than 0.5 or 50%, by the way. The proportion means we're talking about population proportion P, and it says is greater than 0.5. So P is greater than 0.5 or 50%. Next statement. The population of college students has IQ scores with the standard deviation of 15. So now we're talking about standard deviation, sigma, and it's equal to 15, sigma equal to 15. Now let's look at opposite of these claims. If we're saying that the mean body temperature is less than 98.6, what is the opposite? Well, the opposite will be that mean is greater or equal 98.6 degrees Fahrenheit. In this statement, P greater than 0.5, the opposite statement will be P is less or equal 0.5. The population of college students has IQ scores with a standard deviation of equal to 15. What is the opposite of equal? Well, that would be not equal to. So sigma is not equal to 15. After we formulate our claim and write it in symbolic form, we want to identify null and alternative hypothesis. The null hypothesis, also denoted by H0, is a statement that the value of population parameter such as proportion, mean, or standard deviation is equal to some claimed value. The alternative hypothesis, denoted by H1 or H or H, is a statement that the parameter has a value that somehow differs from the null hypothesis. For methods of this chapter, the symbolic form of the alternative hypothesis must use one of these symbols: less than, greater than, or not equal to. Let's look at our statement. Our first statement: the mean body temperature of humans is less than 98.6 degrees Fahrenheit. The claim is that mean, mu, is less than 98.6 degrees Fahrenheit. The opposite of the claim is that mu is greater or equal. Opposite of less is greater or equal 98.6 degrees Fahrenheit. Let's identify the null hypothesis. The null hypothesis is the statement that our population parameter is equal to So looking at these two claims, the claim and the opposite, we're choosing the claim that has the equal sign in it. It's opposite claim. Mu is equal to 98.6 degrees Fahrenheit. This is our null hypothesis. For the alternative hypothesis, we'll pick this statement. We already used this statement, so we cannot use it twice, and it's our original claim. Mu is less than 98.6 degrees Fahrenheit. To make it easier and more structured, we'll follow these steps of hypothesis testing. Step 1. Identify the claim. Step 2. Write the claim in symbolic form. Step 3. Identify the null and alternative hypothesis. That's what we just did. Step 4. Choose the significance level based on the seriousness of a type 1 error. Type 1 error is the mistake of rejecting the null hypothesis when it is actually true. The symbol alpha is used to represent the probability of a type 1 error. Make alpha small if the consequences of rejecting a true null hypothesis are severe. The values of 0.05 or 0.01 are very common. Hypothesis tests are also called tests of significance. Before we use the probability to determine when sample results are significantly low or significantly high, remember the graph over standard normal distribution, with the mean equals 0 and the standard deviation equal 1. We consider any value that is above 2 standard deviations, right here, to be significantly high. And the values that are below 2 standard deviations we consider to be significantly low. In this chapter, we will formalize those concepts in a united procedure that is often used throughout many different fields of application. Will be considered the critical region or rejection region. Rejection region is the area corresponding to all values of the test statistic that caused us to reject a null hypothesis. In this graph, the critical regions are shown in green. The sign of the alternative hypothesis will give us a clue which tests are we using, two-tailed, left-tailed, or right-tailed test. If the alternative hypothesis has a not equal sign, the test is two-tailed, and the critical region is located in the two extreme regions, or tails, under the curve. If the alternative hypothesis has less than sign, then the test is left-tailed, and the critical region is located in the left tail under the curve. If the alternative hypothesis has the greater than sign, then the test is right-tailed, and the critical region is located in the right tail under the curve. In other words, the direction of the sign of the alternative hypothesis will show us the direction of where the critical region is located. If it's not equal, then it's going to be a two-tailed test. If an alternative hypothesis has less than sign, it's going to be on the left. If alternative hypothesis has greater than sign, then our p-value and our test statistic is going to be on the right. Step 5. We want to identify the test statistics that is relevant to the test and determine its sampling distribution, such as normal, t, or chi-square. The test statistic is a value used in making decisions about the null hypothesis. It is found by converting the sample statistic, such as sample proportion, p-hat, sample mean, x-bar, or s, standard deviation, to a score such as z, t, or chi-square, with the assumption that the null hypothesis is true. To find the test statistic, we can either use the formulas or we can use technology, graphing calculator, StatCrunch, etc. Remember, for proportion, when we're testing population proportion, we are using the z-statistic. When we're testing population mean and sigma is not known, we're using t-statistic. When we're testing population mean, mu, and the sigma is known, the standard deviation of the population is known, we use z-statistic and we use this formula. When we're testing standard deviation of the population, we're using the formula for the chi-square distribution. Step 6 is to perform the calculations using p-value or critical value methods. We can also test our hypothesis using the confidence interval method. But this method could result in different conclusions since it uses an estimated standard deviation based on the sample proportion, whereas p-value and the critical value methods on the claimed proportion p. When we use p-value method, we're comparing the p-value with the significance level we picked, depending whether it's left-tailed, right-tailed, or two-tailed. If the p-value is smaller than our significance level, meaning we're in the critical regions, right here in the green, we reject the null hypothesis. If the p-value is greater than our significance level, meaning we are in non-critical yellow regions, then we fail to reject null hypothesis. There's an interesting saying about it. If the p is low, null must go. So, other words, if p-value is less or equal alpha, then we reject null hypothesis. If the p-value is greater than alpha, then we fail to reject null hypothesis. Remember, if alpha falls in non-critical region, we fail to reject null hypothesis. If alpha is in the critical region, which means it's smaller than our alpha, then we reject the null hypothesis. Similar conclusion arises from the critical value method. If the test statistic is located in the critical region, in the green area, meaning it's greater than our critical value, then we reject the null hypothesis. If the test statistic is located in a non-critical region, right here, meaning it's smaller than our critical value, then we fail to reject the null hypothesis. Let's look at how to find the critical value. Say we use alpha equal to 0.05. The test was the right-tailed test, so our critical region is located on the right, and our critical value is going to be positive. If it's left-tailed, our critical value is going to be negative. Z is going to be negative on the left side. Our claim was about population proportion, so we use z-test statistic. We'll need table A2 to find z value that corresponds to the area to the left of our critical value. Now, if our alpha right here is 0.05, That means that the area on the left of the critical value is 1 minus 0.05, which is 0.95. Let's look at the table A2 to locate z-score that corresponds to this area. Our z-score is positive, so we'll go to the positive z-scores, and we will look for the area to the left of our z-score that is equal to 0.95. Remember the areas or probabilities located in the middle of the table. Here we go, 0.9495 and 0.9505. Our 0.95 will be located in between these two scores. And we can scroll down. The z-score is equal to 1.645. Let's write it down. Our z-score is positive 1.645, and it's positive because it's located to the right of the mean. Last step is to restate our decision about whether to reject or fail to reject null hypothesis using non-technical terms. Like if you were talking to someone who did not have a background in statistics and would not have a clue what the terminology is. When we rewrite our decision in human language, we need to pay attention to a few details. First, whether our original statement included the equal sign or not, or does not include equality. And second, whether we reject or fail to reject the null hypothesis. For example, if our original claim does not include equality, and we reject the null hypothesis, then we write conclusion as there is sufficient evidence to support the claim that, and we restate the original claim. If our original claim does not have equality and we fail to reject null hypothesis, then we write conclusion in these terms. There is not sufficient evidence to support the claim that, and we rephrase our original statement. Now that we're familiar with all technical terms and procedures, we're well prepared to put our knowledge in practice and test the hypothesis about the three population parameters: population proportion, P, population mean, mu, or population standard deviation.